Sorry, I had made a slight mistake with the code. Okay, so we had it into this form here where we've got our psi of n, which is fantastic. And so now we know that g of s, this Mellon transformation, which we are going to do for any value of s, but then evaluate it specifically at s is equal to 1/2 in order to evaluate this integral, is just equal to gamma of s times y psi of negative s. So plugging that in, what we have is gamma of s, and all I've done here is I've replaced psi of negative s with its definition. So we've got negative s here, negative s here. So negative s plus 1, 2 times by negative s plus 2, which is just gamma of s, gamma of 1 minus s, so 1 minus s here. And then we've got gamma of 2 minus 2s. So now we've got our g of s, and so in order to be able to resolve this integral, we just need to evaluate it at 1/2, and then remember that we just need to multiply it by 1/2 out the front in order to solve the integral. So g of 1/2 in this case, again, all I'm doing is just replacing s with 1/2, is gamma of 1/2, gamma of 1 minus 1/2 over gamma of 2 minus 2 times 1/2. So I've got gamma of 1/2 here, gamma of 1/2, which is just gamma of 1/2 squared, divided by 2 minus 1 is just gamma of 1. Now, the gamma of 1/2 is equal to the square root of pi. I've said this in other videos, but if you would like to see a proof of that, leave a comment, and I'll happily put up a video to illustrate that. But we've got the square root of pi squared divided by gamma of 1, which is just equal to 0 factorial, which is 1. And so the square root of pi squared is obviously just pi. Pi divided by 1 is just equal to pi. And so therefore, the integral from 0 to infinity of sine of x over x, which is what we need to find, is equal to 1/2 of g of 1/2, which is 1/2 of the Mellon transformation of this modified version of sine of x, which is what we have here, is equal to 1/2 times by pi, which is just equal to pi over 2. And so there we have it. We now have our third method of being able to evaluate the integral from 0 to infinity of sine of x over x dx. And in this case, we use R's master theorem, or I'm going to try once more, and I hope I'm not insulting anyone, especially the Indians. Ramanajun's master theorem. We're able to evaluate this very easily. Okay, so just like with all of my other videos, if you like it, please like the video. If you like these sorts of videos and you'd like to see more, please subscribe. If you have any requests or any suggestions or criticisms in any way, please comment or send me a direct message. Otherwise, have a great day, and I will see you with the next video. Okay, bye.